Hello and welcome to the second Erlang Solutions webinar. My name is Mladen Miličić and I am the Solutions Director here at Erlang Solutions. Today's webinar represents a continuation of a series of webinars we are looking to organize across topics of interest in the world of Erlang and dealing with solutions based on the Erlang programming language. Our topic today will be dealing with one of the most successful Erlang-based solutions we have created to date, a powerful, affordably scalable, and massively concurrent messaging platform called MongooseIM. The story of MongooseIM will be told with the backdrop of a very successful implementation of the solution that we have performed with one of our long-standing esteemed customers. I'm of course talking about the implementation of MongooseIM with ooVoo Communications, a company blazing the trail in video chat solutions. With this being the second in the series of webinars we are running, please excuse any technical issues we may encounter today. To start by telling you a bit about Erlang Solutions, we are a products and services orientated company, completely devoted to the Erlang programming language. Since our founding in 1998, we have worked with organizations and individuals using Erlang, helping evolve the language and supporting people and businesses using it. Today we have 70 people across our offices in London, Stockholm, Krakow and Budapest, and working on projects across the globe. We fly the Erlang flag and are keen on creating value and competitive advantage for our customers across industries and through the unique features and characteristics of Erlang as a language. We are quite ambitious in development of Erlang-based products, and we work to create lasting partnerships with our customers. I'm really pleased to say we have two speakers joining us today and whom we have carefully selected as best invited to tell you about MongooseIM. My colleague and the Erlang Solutions Krakow office lead, Michal Slaski, will start us off with a technical overview of MongooseIM. Michal has spent years working on and with the MongooseIM platform, and he's also a member of the XMPP committee, helping steer the development in this area. MongooseIM characteristics sound unrivaled on paper, but ultimately the proof of capabilities of the MongooseIM platform surely lies in its practical implementations to date. This is why I'm pleased to say that our second speaker today will be Alexander Fok, the Director and Systems Architect at ooVoo Communications. ooVoo have been a long-standing client of Erlang Solutions, and Alex has personally taken a pivotal role in implementing MongooseIM within ooVoo environments. Alex will therefore be in a position to share the intricacies of the system and its key features from a perspective of a customer of ours who lives with MongooseIM every day. Please allow me to finish by saying you are welcome to post questions throughout the duration of the webinar by using the chat facility. Our speaker, Alex Fok, will answer as many questions as time allows at the end of the webinar. If any questions do go unanswered, you are welcome to raise them via email using the following address, webinar@erlang-solutions.com. That's webinar@erlang-solutions.com. If you're interested in learning more about MongooseIM or wish to establish whether it may be a solution for the challenges your own business may be facing, please feel free to contact me directly. My email address will be displayed in one of the final slides of the presentation we will share with you today. The same goes for any other questions you may have. Feel free to contact us. I would now like to hand over to Michal Slaski, who will be glad to tell you about MongooseIM.
Thank you, Mladen. Hello, my name is Michal Slaski. I work with Erlang Solutions for over 7 years. And in the first part of today's webinar, I will tell you about the messaging server in Erlang, which we call MongooseIM. So what is MongooseIM? It's a messaging server which powers projects in social media, gaming, and telecoms. Our focus is on systems demanding high volume traffic. It could be many online users connected, or it could be high volumes of messages, or both. As you will learn later today during the webinar, MongooseIM is a distributed system, and it scales quite well on clusters of tens of machines. We will talk about scalability quite a lot today, but there is also one more aspect of MongooseIM which helped it to be successfully deployed in many projects. It is its modular architecture, open industry standards that MongooseIM is based on, and open technologies, which make it highly customizable. I'll give you some examples where Mongoose could be and has been successfully deployed. For example, in telecoms, the chat feature is a part of standard communication software, so you can find different products in this area with the chat feature. In social media, messaging is also the key part of social websites, with the real-time web applications showing on the market today. This might be an interesting solution to power your chat feature of social media sites. In gaming, we could power multi-user chats, which are integral part of the gameplay. So those are just some ideas and areas where Mongoose could be and has been used. MongooseIM is based on XMPP, which is an open standard protocol used for Facebook Chat, for Google Talk, but also many other messengers. And as the XMPP protocol has been already widely adopted, there are quite a few libraries and client applications that could be used with MongooseIM. For those of you who are not familiar with XMPP, I'll have some properties listed here. First of all, it's an open standard, which is formalized through some RFC documents, and extensions are published through the XMPP Software Foundation site. So this is truly open standard, where also the community can post new ideas and discuss new extensions to the protocol. It's secure, with channel encryption and strong authentication mechanisms. It could be also isolated from public network and powered just your internal solutions. It's flexible, as in new modules can be added, new features can be implemented using XMPP protocol, not necessarily following the standards described on the XMPP standard software foundation side, but some specific elements which require, which your application would require. So this is an XML-based protocol, and it's quite flexible in terms of messages. Architecture of XMPP is decentralized, meaning that anyone can run XMPP server, and there is no central master server. So servers will just federate with each other, and this is how you can, for example, talk to the Google Talk users through the server-to-server federation. XMPP also solves some of the scalability issues when comparing polling approaches. And it's proven because it's been in use for quite a few years now. There are very many implementations and deployments, and effectively millions of end users using XMPP. Okay. Now, what features Mongoose has? So it supports WebSockets, XMPP over WebSockets. This can be truly a key feature for modern chat-enabled web applications. It also supports some other extensions, which are called XEPs. You can find a full list of such extensions on the XMPP.org website. I listed here a few that we support in MongooseIM. This is multi-user chat, service discovery, vCards, privacy list, and private storage. On our roadmap, there is also implementation of XMPP over HTTP called BOSH, which we are planning on releasing soon. And there are also other features which are either requested by the community or we have on our roadmap, and they are being developed in branches. Because you need to know that MongooseIM is also an open source project, and you can follow it and find source code on our Erlang Solutions GitHub account. As I said, MongooseIM is very customizable, and a lot of custom modifications have been built on top of it. One thing that we have learned over the years is that there is never a one-size-fits-all solution for complex messaging platforms. So often our team is hired to develop custom extensions dependent on customer needs. And examples would include push notifications to mobile devices in case some users are offline and cannot receive an instant message, custom authentication plugins to help Mongoose integrate with existing environment, reliable message delivery in mobile networks, and many more. We have developed an open source, also regression test suites that cover most of the source code. And this greatly helps when one modifies core components or adds new components. So this is also an interesting feature of Mongoose. This open source regression tests available also on our GitHub Erlang Solutions account. In this slide, I'm trying to make it a bit more clear how MongooseIM can be configured to achieve target capacity. Let me explain this slide a bit. For small installations, Mongoose should be perfectly fine with Erlang database, which is called Nisia. So as long as the number of registered users, online users, and so-called roster bodies is like less than 100,000, it should be perfectly fine to deploy Mongoose with the standard Nisia configuration. However, if you require higher volumes of traffic or higher number of users registered, we would advise you to use one of the alternatives. For example, for storing authentication data or roster data, we could use MySQL. In this slide, the authentication square indicates that there are different pluggable authentication backends, one for Nisia, one for SQL databases. It could be also an external script you want to use to authenticate users. Also, if even higher numbers are required, I'm talking about million of online users, Nisia, which by default is used for session management and for storing sessions, could also be not enough. It could be that it will not fit in RAM, in which case we would advise you to replace it with Redis. MongooseIM supports Redis as a storage for transient data, like session data. And this actually helps achieve Mongoose even higher numbers. Please note any questions you may have, and I will be happy to answer them towards the end of this webinar. Okay, now in the second part, I will want to share some test results with you. We have some test environment here with the almost latest Erlang OTP and version, the latest Mongoose, some other software using this test is listed here. And let me show some of the results. So we have two kinds of configurations. One with a dedicated box on which MongooseIM and MySQL were installed. The other one with several Amazon EC2 instances on which MongooseIM, Redis, and MySQL were installed. But let's start with the dedicated box configuration. It's an 8-core AMD with 32 gigabytes of RAM. And load tests were designed to first log in a number of users. Each user has 100 buddies in its roster, or contact list, if you like. And then the load test will not reflect behavior of human users, but they give us an idea of what is the capacity of a system under test. Such tests should also help find bottlenecks and generally speaking, profile the system. First test here is aiming at logging in as many users as we can. So we will be aiming at logging in 400,000 users on this box. People will arrive like every second. We will log in 150 users. Each user has also its contact list populated with 100 contacts, but those users are rather shy. There will be no messages sent between them. Let's see how this goes. In this slide, Mongoose is red. The lower, the better. You can observe CPU stable throughout the test. It's about 70% of CPU resource. And the nice thing about the Erlang OTP technology, on which MongooseIM is based, is that it has support for SMP architectures. In our case, it's an 8-core AMD processor. So the support is built into the Erlang virtual machine, and effectively, MongooseIM can scale well from dual-core through quad-core, 8-core, and beyond. In my next slide, you will see memory footprint of Mongoose. Again, Mongoose is red here. The lower, the better. And we can see that once we managed to log in all 400,000 users, we consumed roughly 22 gigabytes of RAM. So this box still has a spare capacity of 10 gigabytes of RAM here with 400,000 users logged in. Now, another test that we tried on this configuration is aiming at generating maximum load, maximum traffic, and see how many messages per second we can push through the system. So now we have decreased the number of users to 75,000. And let's see how many messages per second we can push. We will be aiming at 21,000 per second. This is first slide showing CPU utilization again. Now you can clearly see two phases of this test. On the left-hand side, you will see the logging in phase. People are logging in. Then there is a short break, and then people start to chat. So you see that once we reach 21,000 messages per second, we get a quite stable condition with 80% CPU. Here is another slide which shows RAM during the test. Again, you can clearly see the two phases, one when people are logging in, second when they start to chat. So we need some extra few gigabytes of RAM to allocate it for this ongoing traffic. Mongoose is again red here. All right. Now, another environment that I would like to share with you today is based on Amazon EC2. So we have 5 instances. Those are extra large instances on Amazon with standard AMI images. 3 of them will run MongooseIM. Now we will replace Mnesia in favor of Redis and for storing session data, and we'll keep MySQL as data storage for all other persistent data, like rosters, passwords, and such. Okay. We will increase the, we call it arrival rate, meaning how many users per second we want to log in. The user count is roughly the same, it's 380,000. And we are pushing 8,000 messages per second. Now on the Amazon EC2, there are some different characteristics of the system. For example, the Tsung tool that has been used for generating load would behave a bit differently comparing to Tsung run at our office environment. So this is the maximum message rate we could achieve, 8,000 messages per second. But we are quite confident more could be handled. Anyway, let's see how this looks on the graph. Here we need to discuss this because it's slightly different from the other slides where we had just one Mongoose line. Here we have actually three. They almost disappear behind the purple one because the characteristics of all three Mongoose nodes are pretty much the same. But you can see that here the higher the better, but the memory footprint is quite stable on all three machines where we start to send traffic after we have logged in all the users. Around 4 gigabytes of RAM remain available. I also put Redis as the blue line here to show that this box had a lot of free memory available yet. And here the next slide is again trying to plot all 4 boxes on one graph showing CPU utilization. So you can see again clearly the two phases. The first phase when we try to log in all the users, all the Mongoose boxes were busy, 80% of CPU utilization. Redis was quite busy, 20%. And there was a break and we started to send messages where again, we can see that the Mongoose boxes used only 60% of CPU. Also Redis was reasonably low as far as CPU is concerned. I mean, keep in mind that also those extra large instances are not as powerful as the box, the dedicated box on which we executed previous tests. Again, I encourage you to make notes, ask questions that I will be happily addressing later. And that's pretty much it I had. I just wanted to sum up now some of the benefits of MongooseIM. It's a proven solution from an Erlang-focused company. This platform has been deployed in production quite a few times so far. Rapid deployment. We already pre-packaged MongooseIM for Linux and Mac OS, but it also has a nice build tool which allows you to build and deploy Mongoose. Interoperability ensured by the XMPP open protocol. This is also clearly a benefit of this platform. And the fact that Mongoose is running on Erlang OTP makes it efficiently use multi-core platforms. So as you have seen, saturation of multi-core CPUs was quite high, which is good. Another thing is its customizable components, like pluggable authentication. So this should allow you to integrate the platform with any existing systems that you have already running. All right, that was it from me. Thank you. I will speak to you later when answering some of the questions. I will now pass over to Alexander.
Hello, everybody. I'm Alex Fok. I'm system architect of ooVoo, and wanted to share with you our experience in implementation of MongooseIM. The times when we started to work on this project with Erlang Solutions. We called it Jeopardy. Whom that is not familiar with ooVoo and what we are doing here, ooVoo is a video conference provider, and ooVoo is today about even more than 70 million customers worldwide, mainly in the US. and ooVoo provides free up to 12-way high-quality video service, and it runs on several major platforms like PC, Mac, web-based client, on major mobile platforms like iPhone, iPad, Android, and it has, of course, a Facebook application. In last year, we delivered more than 10 billion video minutes worldwide. Now, what is done here in ooVoo with MongooseIM, we already had service up and running, the video service, and part of video service, we also provide our customers with instant messaging, both one-on-one and group chat, and we maintain in real time presence of the users, and we also maintain rosters and keycards and all the privacy settings or block lists of the users. And we already had some commercial XMPP server that we used at the time. It was about 3 years ago, but we met serious scalability problems of the systems that we had. Scalability and stability, actually. So our main challenge was scale, because ooVoo service is constantly growing, and ooVoo acquires a lot of users every day. So we had a requirement to build a system that actually can infinitely grow, or we can deploy, in other words, we can deploy scale units of the system as required on demand. That days we had 600 online users in daily peaks. We have total 10 million registered users, and all those users generated about 500 messages per second on daily peaks. After several months, even almost 1 year of hard work with Erlang Solutions engineers, we delivered first scale unit of MongooseIM. It was delivered on physical hardware. At times we didn't feel comfortable with any other solutions, so we purchased strong CPUs, best CPUs at the time that were available in the market. Every server had 32 gigabytes of RAM. We made throws, load tests, and we eventually delivered the system to production. Everything went well, more or less. We had several weeks or months of production new production system that we had to fix some problems and to extend it thoroughly. And since then, we developed a lot of new functionalities based on our experience together with the Erlang Solution engineers. Like, for example, we found out that the original XMPP Federation implementation was very not efficient. So we developed a proprietary mechanism that is based on the standard scheme, but is much more efficient. We also delivered a custom authentication mechanism for users, and we integrated MongooseIM thoroughly to ooVoo application, backend applications that can use today, actually using today, different APIs and states of the users that are maintained by MongooseIM. For example, if somebody wants to call to somebody to make a video call, you can check if this user is online in MongooseIM and deliver the call request immediately by XMPP means, or one can send the push notification message to mobile device if and they realize that this user is not online currently. So for this, we thoroughly use MongooseIM REST APIs that we developed and caching as well. Another direction of customization here was driven by our operation department. We developed a lot of monitoring capabilities like SNP counters for every activity that we have today. We delivered a lot of custom logs that provide very high visibility level of what's going on in the system, so we can track different anomaly usage patterns or troubleshoot the problems and see what's going on there. And also we have today extensive capabilities of configuration changes in runtime that allow us to make a lot of changes and to adopt the system during the runtime without any downtime or service interruptions. Today, as you can see, we have several systems already deployed in different geographical locations, and all of them are connected to all other systems. So we have a full mesh of the systems. Every block here, as you can see, IM1, IM2 is actually a scale unit that contains complete architecture inside that we'll look in a second. And all the systems communicate with each other all the time. Here's an example of one site, one of the physical sites that deployed in US and a hosting provider. So we have several, on the top of the system, we have an array of firewalls that protect the access to the system. Behind that, we have hardware load balancers. And here we have actual MongooseIM clusters. Each of them contains a set of worker nodes, set of administration nodes, its local cache for session management, as Michal mentioned earlier. All of these nodes run on top of MySQL cluster database, and they expose REST APIs to other business applications that use intensively MongooseIM in various business flows of that are specific to ooVoo. And all the authentication is done against ooVoo central directory service that runs on top of LDAP servers. Here you can see some examples of monitoring screens that in this case we can see actually some of DB activities and the daily pattern of thousands of messages per second that actually hit our databases. This MySQL databases that we saw before. Here you can see an example of launch of the new domain or new scale unit. It was deployed somewhere in May last year. It's a green picture at the bottom of the page. So you can see that the system on the top of the page, you can see that number of online users dropped significantly when we launched a new domain. So we just distributed the load from existing systems to a new one, and from that point, the load on the system, on the old system, was distributed evenly between the existing scale units and the new scale units. Here you can see an example of custom logs or complex event, we call it, that we also monitor well. In this case, we're talking about a roster event when one user sends an invitation to become a roster of another user. So today we monitor such events in real time, actually, and we can fire alarms when we identify some anomalies in the sensitive events, like somebody sends too many events, or too many events come from the same IP and different users. We definitely saw such cases, and we are able to react fast, actually in real time. Another very important aspect of activity here is XMPP presences, sent received graphs. Actually, this is the main the amount of messages that pass through the systems. And here is another graph that actually also that's presences real traffic from one scale unit toward its cache. We use Redis as a cache layer here, and here actually the numbers can reach relatively high numbers of updates. We're talking about 15,000 hits per second on the whole system to the cache. And actually today, 2 years, almost 2 years after we launched the system first time, we migrated all those servers to virtual infrastructure. We deployed already 11 scale units, or our scale units actually is equal to XMPP domain, and we run them today into different separated geographical locations. Our usage also grown by 10, so we have more than actually we almost in 2.5 million online users daily basis. We have even more than 70 million registered users today, and they generate about 5,000 messages per second on daily peaks. And the uptime of the system is actually amazing. We delivered 99.98% uptime. It means that we had some minor interruptions of the service for a couple of hours last year. Actually, this is all what I wanted to say today. feel free to contact us with any business question. And now I will ask Mladen to close the webinar off with some final information, and we'll be able to ask you questions.
Thank you for that, Alex. This is absolutely the part where we'll be taking questions from the audience, and quite a few questions have arrived during the webinar itself. First of all, just to say, I'm sure you'll all be joining me in thanking Michal and Alex for an inspiring talk on Mongoose. Many thanks to all of you who have joined us for the webinar as well. The next webinar, just to sort of make that little note, is on April 11th. Please join us. We'll be talking about Erlang, learning Erlang, and the advantages of keeping things simple through the use of the language. We will have a chance to hear about the scalability, concurrency, and fault tolerance of Erlang, as well as how easy it is to pick the language up and start using it. Now, I suggest we move on to questions straight away, and then I'll give you a couple of further details to sort of close the webinar off.
Okay, I will start because I already got some questions here. Let me see. So one is MySQL can be a pain to replicate. Are you planning additional backend support for persistent data such as RAYAC? We already tried RAYAC for some data, because this is also a question of capacity planning. There's a lot of data to persist. Some of this is for authentication, so like a table with users and possibly passwords. Another table for the rosters, yet another table for offline messages, and so on and so on. So depending on how big each table is, we could consider RAYAC for this or not. We did use RAYAC in the past for storing some persistent data related to Mongoose. Those extensions were built for some private solutions, custom solutions. Now, if there would be a need for adding RAYAC to the open source MongooseIM, I think we will consider this. Max user scenario is the next question here. How come there is so much CPU usage? The answer is that basically when a user logs in, there is quite a lot of things to do. So we initiate a new connection, then there's some handshake, we agree on the authentication mechanism, then we exchange some messages related to authentication, so there are some database queries to run, then we need to fetch all the contacts from his roster, we need to transform it to XML, transmit it to the client, and if each user has 100 buddies in its roster, this might be quite a long list. And then if you are trying to log in hundreds of users per second, then it all adds up. So it's a combination of the stress put on the database. In the case of the first configuration, it was Mnesia. So actually on the same box we had, sorry, no, it was MySQL plus some logic on the Mongoose side. So this all adds up. But once users are logged in, just persisting the session is quite cheap. It's just, it does not consume that much memory, and it does not consume CPU at all, unless the user is actually chatting. So there's another question related to RAYAC. Can RAYAC be used in place of MySQL for persistent data storage? I think I already answered this question. What were the message sizes? We were using Sung tool for generating the load. Messages were rather small. I think a single stanza with a message would end up being tens of bytes. So the message payload was just some bytes long. Okay, I have quite a few more questions. What the private XML storage is? I mentioned on one of the slides that Mongoose supports one of the extensions. Basically, it allows users to store some data for later retrieval. It's not meant to be a great amount of data, but it's just, it could be some configuration, some other data. There is a detailed description of what the extension is about on the xmpp.org website. It's the XEP number 0049. So I would refer to this description for more details. For the test scenario presented, when loading the roster for each user, was it also a precondition that users on the roster were also logged in? Well, yes and no. I mean, users were logging in. We have, for example, 500,000 users registered in a database, and as they appear online, it might be that they already will have some of the contacts from their contact list logged in, or some of those could be yet offline. So eventually we will end up having almost all the registered users in the database available online. This is at the peak of the test. And so it's not like a precondition that users are logged in when you log in a new user, but eventually they will all end up being logged in. Okay. Does MongooseIM provide a Dropbox functionality? I'm not sure if I get this question right, but XMPP as a technology does specify how users can send each other files or initiate audio calls or video calls. So if we are talking about sending files, then XMPP protocol does define how this could be achieved. However, if Dropbox functionality is like a storage on the server side, then the answer is no. Mongoose does not provide any Dropbox-like storage for files sharing. I mean, I think we don't have that much time to answer all the questions. I will pass over to Alexander now, so that he can also answer some of his questions.
Okay. I see some questions here. Was the downtime related to the XMPP servers reasons? Actually, most of the downtime that we had last year was related to some abnormal activities of our clients, either the software problems or real users, and some MySQL limitations or actually problems. So it required us to deploy several patches even to MySQL. So today we're in much better shape. Actually, we didn't have a complete downtime of XMPP servers themselves. Another question here is regarding custom authentication. It provides some more detail on support for SSO, SAML, Kerberos custom authentication mechanism schemes. Actually, what we've done here, we developed a custom mechanism that was integrated into standard XMPP supported SASL authentication scheme. And this mechanism is based on ooVoo proprietary key management scheme and token generation. And the idea of this mechanism was to allow ooVoo proprietary SSO, single sign-on infrastructure, to be used also by MongooseIM service as all other ooVoo services do today. Another question here is, please provide some information on support for offline messaging in MongooseIM. It's supported according to XMPP standard. It's a certain standard XMPP part we have a table in MySQL called spool, and if the recipient of the message is not available to receive this message, MongooseIM identifies the situation and stores this message in a spool table until this user will log in again, and then this messages will be delivered to this user. Another question here is, what kind of TCP socket configuration is needed to ensure minimal packet drops to mobiles running on GPRS or lesser stable? I'm not sure if the question is related to TCP socket configuration on server side or client side, but actually we do not have, on the server side, we do not have any specific configuration or specific setup for mobile clients. Actually, our clients run on different platforms as PC, Mac, or any mobile platform, and we don't have any specific optimizations for mobile clients on the server side. Only maybe we don't experience any problems with that. We don't think that we have to make some specific optimizations for mobile clients here. Only considerations that should be taken here is that the mobile clients lose a network much more than PC clients. So this is why they reconnect the systems much more than usual PC clients. But we should be adjusted with the proper capacity planning. That's it. Another question here is HTTP admin removed. Yes, we don't use the original HTTP admin of EJBLD. We developed our proprietary one. Another question here is, how many Erlang nodes do you start for about 1 million users? I assume that the 1 million users number refers to online users, because actually we can talk either about online users or about registered users in the database, but registered users is very small numbers. 1 million is actually a small number, so it is not challenging the system. But for online users, in real time, in real life, we allow on every node to have about 50-60,000 concurrent users connected. So it means to support 1 million users, you need about 15 nodes running. But again, these figures are from real life, and these nodes can handle much more load. We tested them with load tests also with Sung, with Erlang Solutions engineers, and we reached at least double numbers in the load in the test labs. But in real life, we don't want to stage the system much, so we do not allow more than 50-60,000 users, online users per server, and they function completely well. I think this I addressed all the questions that we have here.
Okay, thank you, Alex, for that. We had a very interesting question come in from Thomas, and I'd like to pick that one up as well. Thomas is asking, is Erlang Solutions in the professional services business, or do we maintain a commercial branch of MongooseIM, similar to Process One's approach to EJBLD? Well, as Michal mentioned earlier in his elaboration on MongooseIM, Mongoose is open source, and you can download MongooseIM and start benefiting from it straight away. We provide services around implementation of Mongoose and development of new features depending on what your specific requirements are, and there's a cost element around that. We also provide support for your Mongoose implementation, which is obviously highly recommended and something you need to consider. Now, we've exhausted our time for questions, but once again, many thanks to Michal and Alex for a great talk on MongooseIM. Many thanks equally to all of you who have joined us for the webinar. As I mentioned, please join us again on April 11th for our next webinar, which will be dealing with the topic of learning Erlang and how to keep things simple through use of Erlang. You'll have a chance to hear just how easy Erlang is to pick up. And I'm really glad to say that we will have some fantastic speakers lined up. First of all, none other than Robert Verding, one of the inventors of Erlang, and Francesco Cesarini, the technical director at Erlang Solutions, who will give us an opportunity to learn about the language. Now, following today, we will be sending you a short survey to make sure we capture your feedback of today's webinar. Please note that the recording of the webinar and the presentation that was shared today will be available for you to collect on Erlang Solutions' corporate website at www.erlang-solutions.com. Thank you once again, and we look forward to seeing you again on our next webinar.